Okay, let's unpack this. Today we're tackling what might be the Everest of modern mathematics, the Riemann hypothesis.
Right, or the RH, formulated by Bernhard Riemann way back in 1859.
And it's just this beautiful, simple-sounding idea at its core.
It is. The hypothesis says that all the important solutions, the non-trivial zeros, to this one special function, the Riemann zeta function.
They all have to line up perfectly.
Exactly, on a single vertical line in the complex plane. We call it the critical line.
And that perfect alignment, if it's true, it basically dictates the entire structure of the prime numbers. It makes them orderly.
But the traditional tools for proving it, they've completely stalled.
So that's our mission for this deep dive. We're looking at the radical new ways people are thinking about it, how it connects arithmetic, pure chance, and even quantum physics.
Which starts with trying to get the problem out of the complex plane altogether.
Right, bring it back to something more basic, like the work Geoffrey Ligarius did.
Exactly. He translated it into something you could almost check with a calculator. Almost.
So you're telling me a problem about infinity is somehow the same as a simple rule for whole numbers?
That's the amazing part. It all boils down to how efficient a number is with its divisors.
Its divisors?
Yeah. Ligarius proved the RH is true if and only if a certain rule holds for every single natural number. The sum of a number's divisors can never, ever get bigger than a specific boundary, a boundary related to something called harmonic numbers.
So we throw out all the complicated analysis.
You can.
And the problem just becomes a search for one single number that's, I guess, too complex for its size.
Precisely. You're no longer proving something for infinity. You're just trying to show that no finite counterexample exists. It completely reframes the search.
Okay, that's the arithmetic angle.
Yeah.
But now let's shift gears, because here's where it gets really interesting.
This is the quantum chaos connection.
Yeah. In the 70s, a mathematician named Hugh Montgomery was just looking at the Riemann zeros themselves, the data.
He was looking at the spacing between them, the pair correlation, how they cluster.
And the pattern he found, it was identical to a pattern from a totally different field.
From physics.
Yeah.
It perfectly matched the Wigner-Dyson distribution.
So, let me get this straight. The secret rhythm of prime numbers is the same as the physics inside a uranium atom. That just seems impossible.
It's the core insight. That exact distribution describes the spacing of energy levels in heavy atomic nuclei. It's a signature of something called quantum chaos.
Which suggests the zeros aren't just abstract numbers. They could be, what energy levels?
That's the wild idea, that the zeros are the eigenvalues of some unknown quantum system. People have even nicknamed it Riemannium.
And if that system exists, the physical laws governing it would prove the hypothesis, because the operators in quantum mechanics, they're Hermitian, right?
Precisely. And Hermitian operators can only have real eigenvalues.
Which forces the zeros onto that critical line. It would solve the whole thing.
It would be the ultimate link between pure math and physical reality.
Okay. An incredible idea. But we should probably touch on a more skeptical view, one that questions the whole foundation here.
You mean the finitist critique?
Exactly.
Right.
People like Norman Wildberger. Their argument is, what if we just reject the idea of the actual infinite?
If you do that, the whole game changes. If you don't believe in infinite sets or sums you can't actually compute, then things like the complex plane or analytic continuation.
They're just useful fictions. They aren't real.
Right. And for a finitist, the fact that we've calculated, over 10 trillion zeros, and they're all on the line.
That's all that matters. That's the reality.
And they ask, is demanding a proof for all infinitely many zeros a scientific question? Or is it more like theology, since it's beyond anything we can ever actually check?
So, after all this, what does it all mean? It seems like the RH is this grand intersection point.
It is. It's the equilibrium between the discrete world of counting numbers and the continuous world of, say, physics and probability.
And there's this new idea, right, about the structure of primes.
Yes. Recent work shows that prime numbers display something called hyperuniformity.
Meaning they form a kind of crystal.
A quasicrystal, a structure that's perfectly ordered but never repeats itself. It's an exotic state of matter.
And the Riemann hypothesis is the law that guarantees the perfection of that crystal.
Exactly. It stabilizes this incredible structure right on the boundary between perfect order and total chaos.
So if the Riemann hypothesis is really a law of quantum physics that governs energy levels, and this quasicrystal structure, does that mean the distribution of prime numbers is actually a fundamental law of the physical universe and not just an abstract idea in mathematics?